Welcome to the UGC lecture series. This is the EPG Pathashala lecture series and the paper we are talking about is machine learning. In this module, we will be talking about the different types of learning which we are going to concentrate on. Okay. So, these are the people who have created the help to create the content. So, what are the learning objectives of this module? The learning objectives of this module to understand how machine learns from data provided. We have seen already a little bit of this in the previous module. To explore the types of machine learning and their applications, we are looking at different types of machine learning and to know about the representation of data for learning, which again we have just looked at a little bit in the previous module. Some of the keywords we will be looking at is supervised learning, classification and regression. This module, there will be another module in continuation of this, which will talk about other types of learning. Here we are talking about a particular type of learning called supervised learning. So, let us first again just recap on what are the different types of learning. There are different types in which you can categorize learning, but here we are categorizing learning depending upon the extent of feedback that is happening. So, supervised learning is training data which includes the desired outputs, a large amount of training data which includes the desired output. Unsupervised learning, that is the training data do not include the desired outputs at all. So, you are just given a set of input without labels, without the output that you would like the data to give you. Semi supervised learning, which is training data that includes some of the desired outputs, only that is the difference between supervised and semi supervised is supervised you need to have a large amount of data, labeled data, it is called as labeled data in machine learning terms, while some semi supervised you need to have only a very small set of labeled data. This is very important, we will talk a little bit more about this in the next module. Then reinforcement learning, it is a different type of learning where we receive awards from sequential actions. We will go into this in detail again later on. So, we are in this module we are going to concentrate on supervised learning. So, supervised learning, as the name indicates itself, it is given a large amount of data and along with the desired outputs. So, the training data includes the desired outputs and you have to learn a function from examples of the inputs and the outputs. So, you learn to predict output when given a input vector. What is the advantage of this? You can learn complex patterns and it normally gives a very good performance. The disadvantages or cons are, as I already told you, the success of supervised learning depends upon the amount of output labeled data. And here we are talking about as though label data comes very cheap, it is very it is actually labor intensive and to get correct label data is a major problem. We are talking about huge data because most of these learning algorithm depends on statistical significance. So, only if you have huge amounts of data you can claim you can get a good supervised learning model. So, that is the disadvantage of supervised learning. Now, this is a small diagram about block that gives you feel of what is supervised learning. So, the input can be training documents which can be text, which can be image, which can be audio, which can be video, it can be any input, and along with the input for each and every input you are giving the corresponding labels. Okay. Now, when you take the input you will also here we are just assuming they are documents. So, you will have number of features. So, this training in data, that is the data along with the features and the labels is given to the machine learning algorithm. What the machine learning algorithm will try to do is it will create one thing, it will give likelihood or something, sometimes it will try to get a better representation. It will also try, sometimes machine learning is used to do that also, but basically produce a predictive model. Okay. And so, this is the first training phase as it is called. Now, when I want to learn, I mean I want to use the machine learning system, I give it the same test documents and I represent it using the same feature I will take or it is called tagging normally, okay, features of the input data, and then I will not have the label. Okay. The label was given when I was doing the training and I will use the predictive model to find out what the label of the new data is. So, this is a supervised learning. Here the crux is the labels given along with the training data along with the amount of training data you give, such that you can build a proper predictive model. So, that is what you call as supervised learning. Okay. Now, what are the basic steps of supervised learning? One is data collection. Start with training data for which we know the correct outcome, provided it can be provided by a teacher or an oracle. For example, images for which we know the object category. In the previous example that we saw during design of learning system, the characters, the correct characters for the given image. Representation, choose how to represent the data, you format and have decide on the format and the values of each feature. So, that is the, then you do, this is the normal steps. So, modeling, choose a hypothesis class, a set of possible explanations for the connection between the examples and the classes. So, what you are given is, you are doing all this using the input data. So, what you are doing is, you are given the input data along with the label, and you are trying to find a connection between these examples and the classes given or the labels given to you. So, that is our model of the problem, finding out that function or the mapping or the connection. Estimation, that is where you find the best hypothesis for the chosen class. For each class you can choose the best hypothesis. How do you represent the hypothesis? Then we may reconsider the class of hypothesis given the outcome. Sometimes you are not actually having an output or the hypothesis, you are trying to learn a hypothesis. So, it is only a estimate. So, you can change that. Each of these steps, how you do the steps can make or break the learning outcome. So, sometimes it may not give you any proper output also. So, examples of supervised learning, please note any of these problems can also be re-specified as a unsupervised, semi-supervised or things, but normally there are certain class of problems or type of applications that are suited to supervised learning, okay. But it is not that you cannot do it with other methods. So, let us take some of these examples. The examples that you have are disease and diagnosis. So, disease diagnosis, X can be the properties of a patient, for example, symptoms, lab tests, okay. And the function can the output that you have can be the disease or recommended therapy, okay. Now, here the properties of the patient, the features you use can be different also. You can have symptoms, lab tests and doctor's reports of previous cases or his own case. So, it depends on how you want to do it, okay. Then part of speech tagging, this is a typical example of part of speech tagging. So, if you take, what are we trying to do here? Now, what is part of speech tagging? You are giving a grammatical category to a word, that is what is called as part of speech tagging. This is an NLP application or natural language processing application. So, if you take the can, will, rust. Now, can here can take 3 categories, basically 3, I am telling it in a very simple way. So, here can you tell me what this can is? This can here is a noun, or I will can the fruit, in that case can is a verb, or you can have I can run, in which case can is an auxiliary verb. So, you have 3 classes for the word can, okay. Like that for many other words you will have different classes. So, what we want to find out is, given a sentence, what is the past category of that particular word. Here we want to find the past category of can. As you would have already realized, the past category depends on the context in which the word comes. So, the can, will, rust, can is a noun, I will can the fruit, can is a verb, I can write, can is an auxiliary verb. So, it depends on the sentence. In that particular sentence only you can say, you cannot just say can and say it can be noun, it does not make sense. It is only noun because it happens to be in that way in that sentence. Another example is face recognition. So, bitmap picture of a person's face can be given and the name of the person or a property of the person can be the output that you require. So, for all this what we do, why are we calling it supervised learning? You give a list, you give some expressions and along with the features and then you have a label. So, this is the disease, okay. Now, this area is becoming very healthcare as a major area of machine learning, especially in the big data era. There are a lot of disease and symptoms connections, symptoms and I mean disease and drug connections, all that available on the web as semantic. I will not go into detail, but healthcare is becoming a major area for machine learning. So, here you will give the a number of examples. Please note, the examples you give decide on how good your output is finally. Okay. So, this is an important part of you can't just give any input. So, if you give can only with noun in your input, you will get only can with noun, though it may be something else later. So, that along with the feature, and here you have the person space along with the name of the person. Now, you have a class, all these belong to yes, all these belongs to no. So, I have 3 features, color, shape and size, and I have the output. Okay. So, I say blue, torus shape, big, it means it is yes, blue square, small, it means it is y, blue star, small, it means it is yes. There are 2 classes yes and no. Red arrow, small, it means no. So, this is what I will give as input. Now, given this, I have to find out what the output is. Now, this particular way we gave the output, we tried to take all the features and we try, it is a case of overfitting. So, it is not giving a proper output in this case, it is not generalizing enough if you choose the features to be in this way and give the output in this way. So, generalization is very important when you are doing this. The ability to produce correct outputs on previously unseen examples is called generalization. So, if you just give a set of data along with the labels and you give the same data and you select and you get the correct data, it is only pattern matching, nothing to do with learning. Learning happens only when you do generalization. What is the meaning of generalization? You are given a set of training samples along with the label output, from that you learn a model. Now, you give something which is unknown to the system, it should be unknown data, say along with the features, but not the label. You are expected to give the correct label for unknown data, only then as the model actually generalized. The big question of learning theory, how to get good generalization with a limited number of examples. Whatever you do, the number of examples that you have are going to be limited. You cannot give too much of data as input, because you need to feature tag it also, you have to feature tag it. So, how do we do a good generalization? The intuitive idea is favor simple classifiers. This was what was told by William Ockham. We have already seen it in the last module, where entities are not to be multiplied without necessity. That is, do not keep increasing the features unless you feel sure that it is necessary to increase them. That is what he means by Occam's razor. Simpler decision boundary may not fit ideally to the trained data, but tends to generalize better to new data. Now, what he means by this is the decision boundary is an important term that you normally use in this scenario, where the decision boundary separates out. Suppose you have binary class, I am not telling everything is binary class, the decision boundary separates out the class 1 from class 2 or an S from a no. Now, if that decision boundary, if you make it really complex, it will fit the training data exactly, but it will not fit the test data, new data. So, that is why he is talking it is make it as simple as possible. So, now let us again redefine what we mean by supervised learning. Given the examples x and function of x of some unknown function f, a good approximation of x that provides some representation of the output. So, the idea is to the process of mapping a domain element into a representation is called feature extraction. So, the first step is to extract out the features. So, divide all label samples x1 to xn into 2 sets, training set and test set. Then training phase is for teaching our machine, that is to get the model, in other words. So, you have to find the optimal weight such that we are just taking an example like this, f of x y w is equal to y I as much as possible for training the samples x I y y, usually done by optimization, and this is quite time consuming. So, this is a function x I comma w which will give me the output y I. So, we are trying to given the label, remember in the supervised learning we will be given x I along with y I, that is the output that we require. So, we are trying to find a proper function that maps the input to the output. In the testing phase, the performance of this function that we have learned and how you modify it with the weight is validated on the unseen label test samples. You have already got training data, with the training data you are labeling, I mean you are finding the function in this case, and you have a test data with the labels which you have got, you have taken from the input, and then you are testing this function with that. So, that will give you whether it is correct or wrong. So, using supervised learning we have to answer the following questions. What is the instance space? The instance space is what kind of features are we using? What is our label space? What is label? Label is the output. So, what are the kind of learning task are we dealing with? What is the kind of learning task we are learning with? What is our hypothesis space? What kind of model are we learning? Now, we have spoken about all these things in the previous module also, but here we are talking a little more technically. So, instance space is about the features you are using for the input, label space is what is the kind of learning we are expecting, and hypothesis space is another term for how is the model, what is the type of model we are learning. Next is what is the learning algorithm that we are using, and so we are supposed to learn a model, what is the algorithm we are using to learn that model, and finally what is our loss function or the evaluation metric. So, otherwise how do we measure success. So, these are the questions that we are asking. Now, let us take each of these concepts one by one. One is the instance space X. When we apply machine learning to a task, the first we have to first define the instance space X. So, instances X belongs to X, that is the each of the inputs. X is the whole space of input data, input samples if you want to call it that, are defined by features. So, you can have Boolean features, for example, does the email, suppose you want to classify email as spam and not spam, does the email contain the word money. Then numerical features, how does, often does money, see the same money you can represent it using numerical features, how often does money occur in this email, what is the width height of this bounding box. So, these are some of the features you can use for defining the input value. So, here you have the input, an item x drawn from the instance space X, and you have the learned model y is equal to g of x. Output is y belonging to y, where an item y is drawn from a label space y, you know what is the label space. Designing an appropriate instance space X is crucial for how well we can predict y. So, that is again I said that the feature selection is very important. So, some of the possible features, for example, for character recognition, histograms counting the number of black pixel along horizontal and vertical direction, number of internal holes, stroke detection if you are doing online handwriting recognition and so on. These are some of the features that are used for character recognition. General problem of character recognition. Speech recognition, it could be features for noise ratios, length of sounds, relative power, filter matches, it could be many things, it could be even the autocorrelation. There are a lot of features that are used. This feature selection is also an important part, but we are not talking too much about it, we are assuming that the features are given here. Spam detection, presence or absence of certain email headers, the email structure, the language that is used, the frequency of specific terms, for example, money, win, lottery, the grammatical correctness of this text, all this can be used as features. Sometimes these features may not be valid, that means for different, how do you know that one feature, I mean intuitively how do you know that one feature is not important. Suppose you have 3 classes, or let us take the email spam, you have 2, either it is a spam or not a spam. Now, you have a feature, and for example, you have a feature of grammatical correctness, you find that grammatical correctness is good whether it is spam or not spam, then that feature is not important. So, if you are not able to differentiate between the classes using that feature, then that feature is not a good feature, you can eliminate it. Remember, our job is to also eliminate features wherever possible, because then we are satisfying the Occam's razor problem also, I mean Occam's razor principle also. So, this can be a vector space also, for example, X is an n dimensional vector, each dimension can be one feature normally, if it is one feature, normally you do not talk about one feature. So, each X is a feature vector, think of X as x1 to xn as a point in the dimensional so many I mean how many other features you have, that many dimension. So, for example, a 2D feature vector x is equal to x1 x2, for example, here this x is a this is not y, okay, this is x1 x2 and this point x in the 2 dimensional space. So, good features are essential, and there is lot of flexibility in how you choose the features, how you eliminate features and so on. What is the dimension of the features? The number of features increases, the dimension of that vector will increase, the feature vector will increase. When designing features, we often think in terms of templates, not individual features. The choice of a feature is crucial for how well a task can be learned. In many application areas, for example, language, learning, vision, a lot of work, as I already told you, goes into designing or deciding what are the suitable features, and most cases this requires some sort of domain expertise. That is what we call as prior knowledge. Without domain expertise, we cannot learn. Okay? I mean, we cannot decide the selection. So, that is about the instance space X. Now, let us talk about the label space Y. Now, again this is what we previously saw, the item X from the instance space, the learned model, and the item I from the label space. The label space Y determines what kind of supervised learning task we are dealing with. So, depending on how you want your Y, how your label space is defined, that decides on what exactly is the type of supervised learning task. So, the output labels can be categorical, like binary classification. Given X, find Y, Y will either be in -1 or +1, that is one way of doing it. Multi category, given X, find Y, which can be in 1, 2, 3 to k, generally with the loss of Y is equal to function of X. We will come to that, but what we are trying to say is binary classification is spam is a typical example of a binary classification problem. It is either the email is either spam or not spam. Classifying newspaper articles is a typical case of multi-category categorization, where we say sports, business, cinema, and so on. And then the output labels can also be numerical. For example, labels are continuous valued and you have to learn a linear or polynomial function. There I mean for categorical we do not do that, for continuous valued we have to do that. An example of this is rainfall prediction, stock market value prediction, and so on. Another is ranking, that is labels are ordinal and learn an ordering, that is f1 of x1 is greater than f of it does not belong to 1 or 2. Typical example of ranking is a search engine web page ranking. Okay. Outward labels can also be structured objects. For example, a sequence of labels given a sequence x1 to some x L, we have to find out the corresponding y1 to yl. So, here it means they are not isolated. If this happens, I mean all together it has to be found. Sometimes the sequential labeling problem is also simplified into a normal labeling problem also. Hierarchical categorization, given x, find the point in the hierarchy of y, example a tree. So, given x1 x another, so here for example, you can find out that Sachin Tendulkar belongs to cricket, belongs to a game and belongs to something like that. Then prediction, this is also sequential, but here we are talking about time. So, suppose you have x1 xt minus 1, you have to find the values of y, that is x at time t, what will be the value of y at time t. So, here this is similar to sequential labeling only here, but the values of x are associated with time, so are the values of y. X is the instance space and y is the label space. So, given examples of a function x equal to f of x, you have to predict f of x for new examples of x. So, discrete f of x classification, predict whether email is spam or not, regression, predict tomorrow's temperature for example, real values, and f of x can also have a probability estimation, which we will be going into detail later with some probability basics from maths, which we will be covering later in the next module. So, here, so now we have finished with what all? We have finished with instance space, we have finished with label space. Now, we are talking about models g of x, which we used here. We need to choose what kind, I am not repeating this, we need to choose what kind of model we want to learn. We want to find out this g of x. So, suppose you take this hypothesis, can you learn a function given the samples? For this example, we have 2 to the power of 4, it is only binary output, but we have these are the 4 features. So, 16 2 to the power of 4, 16 is a total sample space. There are y to the power of x possible functions from the instance space x to the label space y, that is 2 to the power of 16 combinations are possible. So, there are 65,536 possible functions that can map. So, you have to reduce that hypothesis space. So, generalize from the few training examples given and identify the function, generalize from the training examples given. Since the possible hypothesis space is high, we will apply prior knowledge. So, again comes prior knowledge. Where did we use prior knowledge before? We used it for that feature reduction or selection. Here we can use it for building the model. So, hypothesis sample representations, you could have simple conjective rules, you could have m of n rules, we can have linear functions, and then this is the probability distribution you can have. We will talk about that in detail later. Now, let us look at the learning models. You can have linear classifier, that is numerical functions, you can have parametric probabilistic functions, which I am not going to talk about now, just to name a few. Naive Bayes is one, hidden Markov models is another. Non-parametric instance based functions, we will come to this in detail later, k nearest, kernel regression and so on. Non-metric symbolic functions like classification, regression tree, and aggregation, which is bagging, and ADA boost is an example of this. This is just to get you familiarized with the terminology of some of the machine learning algorithms. We will be going into these models in detail as we go along. So, classification, let us take an example of supervised learning. Classification is a typical example of supervised learning. Classification, the training data comes with the labels, and we have to learn the class. So, assign an object event to one of the given finite set of categories. An example is medical diagnosis. Given a set of categories, illness types and a laboratory data, blood test, MRI scan, assign a patient to the appropriate category, appropriate illness. Other example, credit card applications or transaction, you can classify it as fraud or not fraud. Spam, which we have already discussed, you can recommend articles in a newspaper to a particular, this is very important application nowadays, because you can actually recommend to the reader or the person which articles he is likely to read. Document classes, I can divide the documents as politics, business, cinema and so on. So, we will talk a little bit about naive Bayes classifier, which we have just mentioned previously. So, here the train the model using a training set with a category, for example, sports, cricket, news. This classifier model will compute probability for each word, the probability that it makes a document belong to each of the considered categories. So, what we are trying to do here is, I want documents are given, I want to classify it as sport, cricket and so on. So, what I will do is, what is the input? Remember, the input is a set of documents along with the category. Set of documents has to be represented. So, maybe it will be a set of words along with the category. Now, I say that if cricket or bat or ball or score comes, then the probability that it belongs to sports is high, okay, like that. Now, as you can realize, as we the words that we choose, the features that we choose are here in this case words are very important in deciding the classifier. The probability is used to see the probability of that particular word for that particular classification. How do you decide the probability? Given the large amount of input data along with the labels. So, this is a test, this is a test with the test data set. You can try this out, and some details are given in this link. So, in the supervised approaches such as classification, we will have access to both the data point and the target value or the label. So, you have to identify a function that gives that particular label value. So, we identify which of the n classes a data point x belongs to. X is a column vector of feature values. So, these are the feature values, you have to find out what it belongs to. Now, this is an example of a single feature classification, one feature only. So, classification of fish, the feature that we are using is length alone. So, the length. So, the salmon is shorter than sea bass. Classification is based on length, the threshold value probably could be 5, but it gives an error rate of 34%. For threshold value of L is equal to 9, it gives an error rate is still 20%. So, if you base it only on that. So, for example, if you take L is equal to 5, you will get this is sea bass, I mean these are the values that you have. So, you can see that this one feature alone is not sufficient, and thresholding is not sufficient to find the model. So, you can also use lightness alone. If you use lightness alone and you give a threshold value, you get only an error of 8%. You can check out this example as we go along later. So, this is an example of how the line will divide the classes into two, binary in this case. Now, we had already spoken about underfitting and overfitting. So, this is underfitting, because what you are doing is you are just putting a simple model and we are assuming it will come correctly, but as you can see some are here also this class. This is overfitting, you are exactly fitting, so it will not generalize, and this is a generalized fitting probably which is just right. So, underfitting is a simple decision boundary, underfit the data, the chosen model is not expressive enough or not generalized enough to fit an unknown data. So, there is no way to fit a linear decision boundary for the data given, so that the training samples are well separated. So, the idea here is the training samples should be well separated, they are not. If you look here, they are exactly separated, but then that is too overfit, that is overfitting. So, this is an example of just right. Okay. Now, the model learning error is too high when you do that type of fitting. The same thing is true for overfitting. We have discussed overfitting quite a lot as we went along. So, we have to test the error and we have to check out what we should do. Regression is again supervised machine learning technique for estimating relationship among variables. Only thing is the label will belong to a real value. So, the measure of relation between mean value of one variable and the corresponding values of the input variables is what we are looking at. One type of regression is binary regression, and again details can be had from this set. Some examples are voltage and temperature connection, processes memory and the power consumed, this is the output, protein structure and the energy, robot arm controls and the torque. In an example shown next, y is equal to 2x plus 80 is the best fit for the points given. Given a new point, we can find that something y is equal to 180 from the regression equation. So, can also be a polynomial. So, for example, here this is the linear regression for the given points, y is equal to 2x plus is the best fit for this points. So, given 50, you can find the approximate value. So, this is weight in points and height in inches, this is the obesity ratio. So, some of the popular frameworks tools used are VICA, CARET2. VICA is a good tool, you can try it out. GATE is for NLP, OpenNLP, these are all for NLP. This is for some of the complicated modules, this is for big data becoming very, very popular. So, summary, what we did here is we discussed a particular type of learning which is a supervised learning. Here we categorized this based on feedback if you remember. We discussed the steps involved for supervised learning specifically and explain the different types of supervised learning like classification and regression. We will see the other types of learning based categorized based on feedback in the next module. Thank you.